Well done, guys. I wasn't expecting such a full room at 5. So, well done, you. You should be proud. I will probably not be here. But don't worry, this is not going to be, hopefully, a boring talk. I'm going to take it, hopefully it's going to be fun, it's going to be quite light and enjoyable. So I'm going to talk to you about a library that I wrote that is built on top of Scalacheck. But what I would like to show you is not my library. I mean, my library is awesome, but you guys know that already. But how open source can be fun and cool. How I managed to build a library but by just doing nothing. So this talk is going to be how does people code and be cool. I'm going to show you how with 4 lines of code, and there could have been 1 if I didn't put a type for each line, I managed to create a library that people are actually using, and people are actually excited about, and people are thanking me for those 4 lines. So you can do this as well, right? I'm not a genius. You can contribute to open source as well, okay? So please do open source and be cool like me. Well, I'm not cool, I just look cool. So let's start our journey. And let's imagine our cool startup. Our startup is a real startup. So they don't have a lot of money. You can see from the logo that they are a real startup, right? So they probably don't have a lot of money to pay for the infrastructure to run our application. And they have a pretty standard structure. So they have the classic monolithic that is called core with way too much logic that does way too many things, with a database where they are dropping data. And then they have a REST API so that they can serve the data. And they integrate to third parties, they call other services, right? So our goal is to test our system, REST API plus core plus database, in a way that we are satisfied enough that things are probably working. So testing is tough, right? There are a lot of different types of tests. There are unit tests, there are the cheapest type of test that you can write, there are integration tests, end-to-end tests, pack tests, mal tests. Yes, they exist, although they are terrible. But you have to decide one type of test to run. And because they are the cheapest, a lot of the people just go with unit tests. But unit tests are problematic. So sometimes you write a unit test and you think your system works, but actually it doesn't work. And you're like, it's okay, I have 100% test coverage. It will work. But it will not. So, you have also security issues with your system, right? And things can get really messy. This is the best. This is the best indeed. So please, no arguments, write integration tests, or at least not just unit tests, right? So we are from a cool startup, so we know we're not happy with just writing unit tests. We want to write integration tests. So that means that we are probably going to have to actually involve our API as well as our database. Okay? So, cool. Hopefully, you're all convinced that integration tests are important, right? That was really fun, I know. So what usually people do is that they write classic integration tests. But what they do is that they predefine some set of data that then they use to feed their integration tests. And then things go wrong, because then, they run their system in production, and they didn't consider all the case scenarios involved in their system, and it simply doesn't work. Like in this case, this system was working when he tested it because it was pouring the water directly into the drain. Okay? So another possible solution that people adopt, it's something that is called Scalacheck. How many people have heard of Scalacheck before? Okay, cool. Most of the people. For those that didn't, Scalacheck is inspired by an Haskell library where basically you write your test as properties, and Scalacheck will verify that your properties are true. The way it works is actually not that smart, in the sense that Scalacheck would generate 100 samples of your data, and then assume that if your test passes for all of those 100 randomly generated sample data, then your property is true. And the reason why it's cool is because if it finds a set of data that invalidates your property, then it will tell you. And it will say, actually, no, your property is not true if you put these inputs into your test. Okay? So this is really cool. So if you can, please do use Scalacheck. And the reason why Scalacheck is really cool is because, again, we are not testing on a static set of fixtures, static set of things that we feed to our test, but we are, our test is completely independent from the input he receives. And if there is an edge case that we didn't consider, then Scalacheck would provide a counterexample. So, it's cool. It makes you think that maybe your code will work. Okay? Scalacheck is awesome, but it also has some problems. And the problems are that you need to relearn how to write your tests, right? So you need to write your tests as properties. And that sometimes can take a while. And also, like in our case, if you are connecting to a database, because it simply repeats the same test 100 times, if you have side effects, it could be problematic. So in our case, we risk to really put a lot of load in our small database. But also there is another problem that people don't realize, is that the way you configure Scalacheck can really affect his output. So for example, by default, Scalacheck would run the test 100 times. But there are cases, like Noel mentioned on Twitter, where everything seems fine with 100 test runs. But if you change it to 10,000, then suddenly you find the bug. Even crazier, if you change it to 1 million, you will find an even crazier bug, right? So obviously, if you are cheeky and you set your configuration to run only once, then guess what? Your test will probably pass, okay? So back to our cool startup. We know we want to run integration tests, but because we are probably using a database like Postgres that doesn't have a good in-memory equivalent database, we want to hit a real database. And we don't have a lot of money, right? So we cannot really afford to use a big database just for our tests. In particular, if we are doing BDD, behavioral-driven development, where our tests are just a definition of what our API should do, then this can be problematic. So if, for example, you have 600 different definitions of what your API should do, and your test takes 4 minutes, if you then use Scalacheck with 100 executions, it means that your tests are going to suddenly be 60,000, and they will take roughly 400 minutes. I wouldn't do that. That sounds too long. But again, testing is really important. We want to make sure that our system is probably correct. It works as expected. So we have seen basically two approaches. The one where we use static fixtures, where the data that we feed to our test is completely biased. And the Scalacheck, that is using completely unbiased data, but has problems when side effects are involved. So is there a compromise that we can use in these cases? And the answer is yes. And is to run the test once, but using randomly generated fixtures. OK? So now we know what we want to do. Let's start thinking how we want to do this. First of all, can we reuse some of the magic that Scalacheck does? Well, the answer is yes. I managed to do that, and I created a library. Boom. Random data generator. Yeah, I'm not good at naming at all. Let me quickly show you how this library works. So if you have case class example that has two fields, a text that is a string, and an n that is an int, you can just say, give me a random example, and it will give you a randomly generated instance of an example. OK? And this is extremely simple. And the reason why it's useful is because when you do BDD, what you are testing the behavior of your system. So you can create a system, a test, that tells, no matter what's the user, when I post to /user, then it should return status code created, and it should verify that the thing that I passed has been created. OK? So we now have an integration test that is run once, and it's independent from the data that has been passed to the test. But there's a big problem with this, right? So suddenly, our tests are no longer deterministic. And that's tough when you cannot replicate a session. So what happens is that every time you run the tests, there is going to be a seed, a number that is going to be assigned to your session. And this seed is going to be used to generate your randomly generated data. So suppose you have discovered that your test on a specific shape, input shape, fails. All you have to do is to read the seed that was selected for the session, put it in an environment variable, run it as many times as you want. Your test is now going to be deterministic because the seed is always going to be the same. And then once you're happy, you fix the bug, or you deleted the test, depending on the developer you are, you can unset the variable and be happy. So this is quite useful because, again, your test now can be deterministic on demand. So again, it's everything about having compromises. So at my cool startup, we started using this. And then this happened. So turns out that we found out quite a lot of bugs. At my cool startup, we had a fairly complex API to maintain that did a lot of side effects associated to the same endpoint. And that's actually pretty cool, because we found out bugs before our clients did. So that's, for me, that's a good thing. So again, more on why this library could be interesting is because your test is completely independent from the input that you feed to it. It means that it's easier to maintain. So let's assume that suddenly now your case class user doesn't have 2 fields anymore, but now it has 3. There is nothing that you have to change. the library is still going to be able to generate an instance of user randomly. And it's really easy to maintain. You have nothing. You have to do nothing to maintain. But even better, for those tests where the shape of your input has some certain properties, you are forced to fix those properties that are really important for your test. So for example, if you're testing that your API would reject the creation of a user that is underage, what you could do is that you could just say random user where the age is 17. So this is extremely readable because you are highlighting that doesn't matter what's the shape of user as long as the age is 17. So that's quite cool, right? But let's see how I managed to implement this library with 4 lines of code, okay? And by stealing other people's code. Cool. So the first element of the puzzle is Scalacheck. And Scalacheck is a really smart library. I didn't mention a lot of the details because they are not relevant to this talk. But don't get me wrong, Scalacheck is not a simple tool. It's really complex and it's really well developed. So that's why I thought let's steal some code. So the main part of Scalacheck, it's called gen. Gen stands for generator. It's basically the logic that tells you how you can generate an instance of type of t. So given a generator, you can get a t back. And arbitrary is just a wrapper around your generator so that it can be available in your scope. So we said that we are going to provide the seeds. It's just a number that we either load from an environment variable or we are going to randomly generate, right? So this entry point is covered. But what about this arbitrary thing that contains our generator? And that's when things get really nice. Because I thought, oh, come on, now I have to go crazy, learn shapeless. But turns out that somebody else already did it. So this is a really powerful library. If you use Scalacheck, I strongly recommend you to use it. And what this library does is that it will automatically infer your instance of arbitrary of t if t is an algebraic data type. What it means that if t is a case class or a CL trait, it will be able to magically generate an arbitrary of t for you. Okay? So, done, right? Let's look at the code. Ready? It can be intense. Okay, so this is the code. Okay? This is the first version of the library. It evolved a little bit, so like we don't do a .get anymore. So I can still be proud of me. But this was the first version of the library. So what this library does is that it imports some shapeless stuff that someone else did. And then we say, give me an implicit arbitrary. Then from the arbitrary, give me the generator. And then apply basically the seed. And for some reason here, we are going to see in a moment why that's the case. They return an option of t. Because again, this code is not meant for this library. I stole this code. So who cares? Let's just do the get. It will work. It will be fine, right? So that's pretty much it. I created a library with those 4 lines. Can you believe that? And people are using it. They're thanking me for that. So the reason why they are using an option is because you can define fairly complex arbitrary instances. So for example, you can define things like that. In that case, can you choose a number from 1 to 100 such that is bigger than 200? No, right? So in that case, they will return none. Reason why their API makes sense. Okay? But now that we have seen how the code is structured, the way we are going to use the library makes even more sense. So every time we are going to use this library, Scalacheck shapeless is going to try to generate an arbitrary t for us. But obviously, it will be able to do so only for case classes and sealed traits. What happens if you have a type that is not those things, like, for example, Java type, like currency? Well, you will just have to define an arbitrary by hand. One thing to keep in mind when using this library is that obviously you need to make sure that the generated test data makes sense for your context. So, for example, when you are generating a string, it will return this crazy thing. If you are storing this string in the database, I will ensure you that it's not going to be found. So what you can do is to say, actually, when you are generating a string, use just an alpha string. And it will generate something like this. OK? And again, suppose you are you have to generate an arbitrary for a case class, and for some reason the generation of this case class has some constraints, then you can define an arbitrary manually. So for example, a person can be Daniela, John, or Martin, and the age will be between 0 and 100. OK? And again, I've done nothing. I just look at the code of other libraries, put them together, learned a little bit about this existing library, and that's it. So it was an amazing experience of learning, but I actually haven't done a thing. Okay. So while I was doing that, I was asking questions around, and I wanted to understand how Scalacheck was actually generating data. And it turns out that they are actually really smart at generating data. Because of the way property-based testing works, they are going to try to generate data in a way that is not uniform. So they are able to identify what the edge cases are. So for example, when generating a list, the list is going to be either really small or really big. They will have some generation where the list is average size, but most of the time they will test the edge case scenarios. Or for example, for numbers, usually numbers are going to be around maxint to double check that the code doesn't overflow. So they do a lot of smart logic when generating random data. So for that reason, please keep that in mind. So this library could be used for a lot of things, but I would suggest you to use it only for tests, and not to like populate a database with some crap. Oops, I said crap. Don't say crap. Because your test is not going to look realistic. It's going to be either really weird strings or really long lists, OK? We started using this library, and life was amazing. We found a lot of bugs, but there was a problem with that. And the problem that our compilation times went up a lot. And the reason why the compilation times went up a lot is because we were heavily using a feature of shapeless, that is type class derivation. It's the idea of generating things randomly. It's the idea of generating type classes at compile time so that you don't have to write them manually. So it's normal, right? The compiler now does a lot of things. It's going to take more time. So over the years, there's been a lot of work to improve the compile time of the implicits. So this slide is from Miles in 2006. So things have improved a lot. But yet, it was taking a lot of time. So can we do better? And then one day at a conference, I found Propensive talking with Zainab, and Magnolia was born, and it was awesome. So Magnolia is dedicated for type class derivation. It doesn't do as much as Shapeless does, and it does some dirty, mutable bars all over the place macros. But it's really performant in terms of compilation time. So I started looking at it. It's like, yeah, this looks really promising. I'm going to really speed up my compilation time. But now I have to learn this new library that John just created. And you know John, he changes the API every 5 days, so... that was painful. And you know, he has so many projects, and now he's focusing on Fury, and I'm like, please work with Magnolia. But it turned out that roughly a week later Magnolia was out, this guy, Valerian, wrote Scalacheck Magnolia. So again, I haven't done a thing. They've done everything for me. So thank you, Valeria. Thank you, John, for these amazing libraries. So all I did was changing my build.spt file, and I changed the dependencies. Just to try it out, see if it would have been a little bit faster. And it turns out that overall we got quite a speed up, 248 average speed up. And that was pretty cool. Again, I just changed the dependencies. We're probably not going to see the numbers. Well, if I change the slide, you're not going to see them for sure, but we basically went down from 1,500 seconds with no caching to 300 seconds with Magnolia. So that for us was like, yeah, we're going to use this, right? So I published another library. So if the original library was called Random Data Generator, and it was using Shapeless, now I have a new library that does exactly the same thing. It just has one different dependency, using Magnolia. So how do I call it? Random Data Generator Magnolia. I promise I will spend more than 5 minutes naming my next library. I promise. So yeah, it was that simple, right? And again, these speed up were really amazing. So you now might be wondering, okay, is Shapeless that? Not quite. So the reason why Magnolia is so more performant for type class derivation is that it does only that. So John went away, crazy mode, and he wrote this crazy macro that does some crazy stuff that is just for type class derivation. It's also a project that it's in the early stages. So for example, the first version wasn't able to infer the type class if the case class had more than one apply method. I believe that now has been fixed. So please help me reminding John that he has Magnolia and he has to improve it. Forget about Fury. Work with Magnolia, please, right? Shapeless is still based on macros, but it does a lot more. So let's not get rid of Shapeless yet. We love Shapeless. It's just that if you are heavily working on type class derivation, please consider using Magnolia. Okay? That was the end of my journey. A little bit of wrap up on the things that I've learned in this crazy development of this library. The first thing is that sometimes you have existing solution. They're not going to work for you. You are going to have to find a compromise. So for our problem, we had to compromise between integration tests using status fixtures and having integration tests and having no integration tests using Scalacheck. And the compromise was this library that generate random fixtures and run the test only once. When using this library, obviously, you need to be careful about the data that you are generating and make sure that the data that you generate makes sense on your context. So, you still have to manually write some arbitrary instances every once in a while. And obviously, I want to stress this as much as possible. If your build fails, please do not ignore it. That's the whole point of it, right? So every time you have a build that fails, stop, ask yourself, okay, let's make it deterministic, set the seed, and investigate why it failed. Okay, don't be lazy. Even though as functional programmers we love to be lazy, but that's another story. And be aware that we are reusing code that it wasn't meant for this library. So if you are using for other purposes, you will see that the data is generated in a certain way. Magnolia is a really powerful tool. It can make your build a lot faster. But please keep in mind that it's still at the early stages, and John and the community has to put a lot of energy to fix potential bugs or improve it. And it's good for type class derivation. That doesn't mean the shapeless is not useful. It just means that for that specific case scenario, Magnolia could be better at compile time. And I want to stress this. I really enjoy Edo's keynote. Open source is awesome, guys. I managed to do this with 4 lines of code, and people are actually using this library. This will be my last slide. Testing is tough, and it's something important. Sometimes it's something boring to do, but we all have to do it. And the reason why testing could be so tough, and I think this quote is really on point, is that when you test something, you can only demonstrate the presence of a bug. You cannot demonstrate that the bug is not there. So we will always, not be so sure that the code is actually working. So that was me. Thank you very much for listening. If you want to have a look at my 4 lines of code, that's the random data generator and random data generator Magnolia. I will publish the slides online, so they will be on my Twitter account. And if you want, have a look at my blog. Thank you.
We have plenty of time for questions, so I hope you're plenty of questions.
Oh, I'm scared. Can we have it here?
Is it personal?
I love you, Morris. You know that, right?
Did you flip to you had the little chart that I had from 2016? Right, so that is not yet in a Scala compiler that you're using. So that will be in 2.13. It's in 2.13n5.
Exciting.
Yeah, and it will also be in 2.12.7, which is due out in a couple of weeks' time. So I would love it if you reran your benchmarks with 2.12.7 and told me what the results are.
We will definitely do. So, hey, there's a challenge there. It's going to be a battle to the last second of completion. Awesome.
Challenges are good for having best of performance and best libraries.
I mean, if you make my code faster, come on, people. Well, I'll be around, so if you want to grab me for questions, you know where to find me.
Okay, thank you, Daniela. Before she leaves the stage,